Alright, hello again. This is Jeff Scott of Blackhawk Technical College. I've been going over the PowerPoint presentations for the Murox MySQL second edition book, the book that will be used for the 152-147 Relational Database Development class for the spring 2016 semester at Blackhawk Technical College. We've gone through the first 10 chapters, so now it's onward and upward to Chapter 11, how to create databases, tables, and indexes. All those will involve the word create. And if you remember from earlier lectures, the word create implies that what we're working with are data definition language statements, DDL. So we want to be able to write DDL statements to create tables, add constraints like primary keys, null or not null, indexes, etc. Write a script that includes all of the DDL statements we need. The MySQL workbench, again, as I have been doing, I'm probably not going to go over that at all. Talk about constraints you can put on tables, things like not null, unique primary key, and foreign key. Describe the difference between a column level constraint and a table level constraint. Describe the use of an index. Describe the use of a script for creating database tables. Describe two character sets that are commonly used with MySQL and the pros and cons of each. Describe how collation works with character sets. And finally, describe two storage engines commonly used with MySQL and pros and cons of each. So, if we look at the example that's right here, we've got create database if not exists, followed by the name of the database. So if we just do this, if we say create database AP like this for accounts payable, and there already is a database that exists named AP, we'll get an error message. But if we do this, if we say create database if not exists, all right, we will get a message back. So one thing they're not showing in here is quite often what people will do before they create a new database is they'll say drop database if exists and then have AP. Okay? So again, you might say first the drop database if exists AP. Now if it does not exist, what will happen is you will just get a warning. It won't be an error message, but it'll be a warning that you're trying to remove something that doesn't exist. But if you say drop this first, and then you can say create database. That's typically the way that it's going to be done. Then to make the database active, so that you can only have one database active at a time in MySQL, and to make it active, what you do is you use the use command. So you say use followed by the name of the database. So when you create a table, so now we've created a database and we've made the database active with the use command, so now we want to create a table. All right, some of the things that we can add, some of the attributes that we can add to our different columns. If we put not null, that means we can't leave that particular thing blank. Now sometimes when it comes in, you might have, for example, you might have two fields that could conceivably work as a primary key in your database. All right, as an example, you could have one field that was called employee ID, or something like that, and another field you could have that was called, I don't know, social security number, which isn't really a good field for a primary key, but that's a discussion for another time. The point is, only one of those would probably be chosen as your primary key. But the other one, let's say that I do choose employee ID, but I want to make sure that everybody in the database still has their own social security number. Then I could put a unique constraint by social security number. Okay, we can add default values if we want, and you've already seen where we've come in and used the auto increment, and you'll see it again in here. So there's a real simple example without any constraints whatsoever. Create table vendors with a vendor ID, which is an integer, and a vendor name, which is a varchar, size 50. All right. But then typically that's not the way you're going to do it. Typically you're going to do it something more like what is shown down below that. So what this says is that, again, the vendor ID is going to be an integer. The vendor name is going to be a varchar of size 50. But the ID can't be null, must be unique, and will be an auto increment field. So it'll start as 1. We haven't not yet said it's a primary key. I guess we haven't gotten to that part yet in the chapter. The vendor name must also cannot be null, and again, must be unique. All right, so here's another example with another table. Now, when you come in and you start to think about primary key, so we've saying vendor ID, it's an integer, and now we're saying primary key, 2 words with a blank between, and auto increment. Notice 2 words with an underline in between. So the only thing consistent about this is that it's inconsistent. Stop for a second. All right, sorry about that. So again, we're coming in here and we're talking about some of these different constraints that you can see right here. So we've already talked about the auto increment. We've talked about the not null. Okay? So notice, if I want to, previously I put the primary key right on the line where I'm defining the table. I should say where I'm defining the attribute. That's called a column level constraint. If I put it down below, then it's referred to as a table level constraint. There really is no difference. Now, I shouldn't say that. Technically, there is no difference. But if the primary key is made up of more than one field, so let's say this was going to be a combined primary key that was going to be both vendor ID and vendor name, then I can't just put primary key on both lines. Then I have to do it like this, where I'd say constraint vendors PK primary key vendor ID comma vendor name, if I was going to do something like that. All right. And well, there's the example. Alrighty. So you'll notice here's a column level foreign key, and here's a table level foreign key. Usually, if it's a single field, you see the primary key up in there as a column level, but almost always for foreign keys, you see it as being a table level. Now, there's nothing that says you have to do it like that. You can set it up basically and do it just about any way you want to do it. All right, but some of these ways may make more sense than other ways to you, and you should, as always, choose the one that makes the most sense to you. All right. Now, you notice here they have the on delete clause, and we've talked about that one a little bit earlier. I just want to say it to you one more time. What that means is, with the on delete clause, what that means literally is, if I am going to remove a record from a parent table, and if that record from the parent table has associated child records still outstanding, I will not be allowed to remove it. All right, that's exactly what this means. Okay, so again, the idea is we don't want to have any orphan records. So, terms you should know. We just talked about constraints. All right. And we talked about putting it at the column level, where you put it on the line where you define the column or attribute. We talked about table level, where you define it after all of the columns have been defined. We talked about not null, which means, as mentioned, you can't leave something blank. We talked about unique. All right, you can have only one primary key. The primary key can be multiple fields, but you can have only one primary key, but you can have as many unique constraints as you want to. So a primary key constraint means the field or fields that are the primary key. Again, that stands for a unique record identifier. We've talked about this previously. All right. And the foreign key we've talked about also. Typically in a foreign key, what you normally have is you take your primary key from your parent table and put it in to your child table, and then it's in there as a foreign key, so that you are indeed able to relate, or I should say even more than that, you're able to have a relationship, create a relationship between the two tables. All right? Okay. Well, the chances of you going in there and creating a table and never having to change the table are especially if the table is going to be around for years and years, they're slim. Because you might want to alter a table to add new columns, modify existing columns, or drop columns that are no longer needed. So what they're going to talk about next is how you do all of those. So here's an example. Alter table vendors, add last transaction date. So what that means is at the end of the table that's named vendors, we want to add a new field. The field will be called last transaction date, and it is of type date. If we had that field but don't need it anymore, then we say alter table vendors, drop column. Now this is actually, there's an add and there's a drop. Now you may or may not remember, but there are 3 commands that are data definition language commands. They are create, alter, and drop. So when you use create, or when you use alter, or when you use drop, you must tell it what you're altering or what you're dropping, or in the case of creating something, what you're creating, what kind of database object. Here's an example where you are putting in a statement that changes the length of a column. Now you have to be careful with this, because if you're making the column bigger than it was, typically that won't be any kind of problem. But if you're making it smaller than it was, you could end up truncating some of your existing data. All right. Here's one that changes the column type. Modify vendor name, now char 100, not null unique. Well, again, you have to be careful. The idea is you create the table, and in an ideal world, before you put any data in it, you'll go back and look at it and make sure every field has got the name you want it to have, the type you want it to have, the size you want it to have, and any constraints that you want it to have. All right? And then you can start putting in data. All right? But again, if you decide later that you want to start changing sizes and you want to start changing data types, there's always the chance that you're going to run into where everything might seem like it's okay, but when you go in and start doing querying, and if it's expecting numeric data and it finds non-numeric data, for example, bad things can potentially happen. All right, so here they're changing the default value. All right, a statement that fails because it would lose data. Well, if this is the case, then it's a fairly new development in here, because I've done that kind of thing before. And this is a problem you can always run into with relational database management systems when you try to change the size of something and you make it smaller. All right, it looks like it's trying to protect you here, which is a good thing. So not only can you add new fields, remove fields, or modify existing fields, you can also do the same kind of things with constraints. So you can add or you can drop constraints. All right, and I don't know if there's really a modify for constraints. I guess you drop it and re-add it the way that you wanted it to be put in there to begin with. So here's something that goes back and it adds a primary key constraint. You may or may not be aware of this. You actually should be, but it is not mandatory. It is not mandatory that you have a primary key. All right, that said, in a true relational database management system, every table in your database will have a primary key. But that said, it's totally possible and plausible that somebody created one or more tables that did not include a primary key. And really that shouldn't happen very often. What could very well happen though is you could decide that you wanted to alter a table to add some kind of a foreign key constraint. That could very well happen. And again, if you're going to be able to add something, you also have to be able to drop it. And there are some examples. All right. You can rename tables. And there's an example of renaming a table, rather. Now, if you look at the middle example there, it says a statement that deletes all data from a table. All right. You know where they show the statement there that says truncate table vendor. That's right, and it does. But you can also say delete from vendor, which will do the same thing. Most of the time, the recommendation is rather than using the delete statement, you use the truncate statement. And the reason for that, they both will delete all the data from the table, but truncate is designed to work much faster. So especially if you've got a database which has got hundreds or thousands or millions of records, all right, it's recommended that you use truncate. Okay. A statement that qualifies the table to be deleted. So here they're giving the name of the database dot the name of the table. Remember, if you try to drop a table, and if it's a parent table and there are still child records in the child table that refer to that record in the parent table, you won't be allowed to do it. You will get an error message. All right. So we've talked about how to create tables. We've talked about how to alter tables. The next one would be indexes. And remember, we talked about indexes previously in the last chapter. You create an index in a very similar way to the way that you end up. So you create an index in a similar way to the way that you create a table. Again, as mentioned here, indexes can be set up to be unique right away. All right, and indexes can contain more than one field. They don't have to just be a single field. They can be, and quite often they are, but they don't necessarily have to be. All right, there's an example of a unique index. When you use the drop command, again, drop followed by the name of the type of object, in this case, index. When you do remove a table, just so you know this, when you do remove a table, any indexes are automatically removed as well. So it's important that you at least realize that that's the case. All right, so here's a script, as it says, that creates a database. So let's take a look at it. It creates the AP database. So really, this is wrong. What creates the AP database is what's right here. This is going to create the tables, and the tables, and the tables, and the tables that go into the database. All All right, so drop database if exists AP, create database AP. So again, if you don't have a database that currently exists named AP, you'll get a warning here. And this will create a new database called AP. This will make the database active. Okay? This will create the first table. The first table has 2 fields in it, and this one here is a primary key. Now notice they did not put auto increment in there. Probably because they haven't talked about it yet. All right, now we've got our terms, our vendors, and I guess some of these are auto increment. So, all right, think about why you maybe wouldn't want these to be auto increment. Okay, because let's say that you started at 1. Do you really want your 34th customer to necessarily be number 34? All right, you may and you may not. So if you did want it to be something like that, you could do an auto increment. And the auto increment by default starts at 1, but it does not have to start at 1. You can start it anywhere you want, so you can tell it where to start. The reason that that's important, and I've given this example before in other classes, and is as an example, I remember going to a gas station in the town that I live in, and seeing on the pumps there was a message on there that we will not accept any check that starts under 500, and I don't mean $500, but I mean the check number. So if you had a brand new checking account, you were on check number 1. Okay, of course they wouldn't accept it. Well, how do banks get around that? Well, I can say I'm starting a new account, but I want my first check, instead of starting at 1, I want them to start at, let's say, 1,000. So it would be a way of getting around that. You'll notice when you look in here that vendors does have the auto increment for the vendor ID. Invoice has it for the invoice ID as well. But and so does, no, this one doesn't. But you should now be able to look at this stuff that's in here, and really, you should be able to look at all the statements in here in slides 29, 30, 31, 32, and all of that stuff should, at least ideally, make sense to you as far as what's going on in there. All right, and they show some stuff in here as far as how it's going to look for the inside of SQL or Microsoft Workbench, MSQL or SQL Workbench. So I'm just, again, skipping that stuff. All right, and let's move on. All right, so we have here 2 commonly used character sets, and for lack of better words, we'll call them the old and the new. The old is Latin 1, and that was designed to basically support English and every other Western language, but it did not support languages from the East. For example, it did not support things like Chinese. All right, but starting with, it's either 5.5 or 5.6, I don't know which one, but MySQL 5.5 or 5.6, now the default is UTF-8, which is the Unicode character set. All right, and the thing about the Unicode character set is it supports every language that currently exists. All right, here's some other things. Again, it's really not that important anymore. If you want more on collations, you can look all that stuff up yourselves. Okay. If you want to see all the character sets that exist on your system, you can type in show char set. So let's try that on here. Show char set. And you notice there's quite a few of them. It says there's 40 in fact. If I want to see the collations that exist on the system, I can type in, instead of show char set, show collation. And you can see there are 219 of those. All right. If you do want more on this, and we will talk about it probably in a little bit more depth of coverage, but it's in Chapter 9, and again, looks like it's around page 340. And on page 340, all right, the author, on 341, you can see the two commonly used character sets, the Latin 1 for the Western European languages and the UTF-8, which is for the Unicode character set. And then they also mention in the chart down below that, or one of the charts down below that, they talk about the 4 collations for the UTF-8 character set. So the character set that's used by the database or by the table or by the column determines which characters can be stored there and how many bytes are used internally to store this stuff. Each character set also has a corresponding collation that determines how the characters within the set are stored. All right, again, you want more on that, look around page 340, 341. Now this is interesting. They talk about how to view this stuff. Notice it's show variables, show variables, show variables. I believe I can just type in show variables by itself. And that shows me all of the built-in variables that exist in the language. And it's big, but there's 452 of them. All right? So you can, as it says, you can specify a character set and a collation, and you can do that at a database level. You can do it at a table level. You can do it at a column level. Okay? And the last thing that's discussed in the chapter here are the 2 basic types of storage engines that are used for MySQL. They are InnoDB and MyISAM. Now, since about, I think, 5.5 version, MySQL version 5.5, InnoDB is now the default. But previously, MyISAM was the default. So what's the difference? If you want to be able to work with primary keys and foreign keys, you need to set the storage engine up to InnoDB because that's the only database engine that supports foreign keys. If you want to be able to do some extra special, for lack of better words, type of searching, then you use MyISAM. And ISAM, as you probably would guess, ISAM is an acronym. It's, what is it? Indexed Sequential Access Method, I believe. I can type in show engines, and that shows me all the different database engines that are allowed. You can see MyISAM is in there, InnoDB is in there with a little bit of work about each one of them. There's also Federated, which, to be honest with you, I had not heard of before. Memory is the only other one I've ever used. Memory is kind of like a scratch pad, so if you're going to be using it for temporary things. Okay? And that pretty much is it for this particular chapter. So again, as you saw, this whole chapter was on the usage of database definition language, or DDL commands, in particular those working with databases, tables, and indexes. Again, we also did come in and talked about the use of collations, the use of character sets, etc. So that's pretty much it for this chapter. When I come back again, we're going to go over chapter 12, which is a shorter chapter on how to create views.